Hello friends, welcome to CENTUM Academy. So in this particular video, I'm going to briefly discuss with you a FRQ question asked in the year 2017. So in this question, I'll just briefly describe what is given to you. Here you've been given a graph of a function derivative, that is f dash t is given to you. And besides, you have been given that the value of the function at -2 is 7. And we need to find out what is the value of the function at -6 and 5. Alright friends, for this I'm going to use a very basic concept which is called the fundamental theorem of integral calculus. Right? Now this theorem says that if f of t is the primitive of f dash t, is the primitive or antiderivative of f dash t, then the integral of f dash t from a to b is given as f of b minus f of a. Right? So exactly the same thing I'm going to use in this question as well. In place of a, I'm going to replace -2. In place of b, I'm going to replace x. And f dash t remains f dash t. And this is equal to f of x minus f of -2. Now we know that f of -2 is going to be 7 as per the problem. So what I'm going to do is I'm going to replace my x now with -6 as asked in the question over here. So integral f dash t from -2 to -6 is f of -6, and this becomes -7. Now, when you want to find out the integral of any function from a to b, you're actually finding out the area. You're actually finding out the area of that function, or area between the function and the x-axis. But remember here, because you are integrating it from -2 to -6, you are going in a reverse process of integration. So this area is going to be a -1. So it's going to be half into base into height, but with a negative sign. So this is going to be a -4. So this will become -4. And let me bring the 7 on the other side. Plus 7 is equal to f of -6. So basically f of -6 happens to be 3. So this value becomes 3. Now friends, in exactly similar way, I'm going to now put the value of x here as 5 and check what's the value that I'm going to get now. So the same concept, I'm just going to start from here right again. So it's -2 to 5 f dash t plus 7 is equal to f of 5. Now what is f dash t from -2 to 5? It's going to be the area of this semicircle plus area of this triangle. Now area of this semicircle is going to be half into pi r square, which is 2 square, with a negative sign. The reason for this negative sign is because this area is below the x-axis, right? So this is going to be -2 pi, correct? And the area of this triangle is half into base into height, which is going to be +3. So your answer is going to be 7 minus 2 pi plus 3. So this is your f of 5, which is going to be your answer for the first part of your question. So this is done. Now moving on to the second part. Okay, so let me just clear off the screen a bit so that I have some space to write on. Yeah. Now, the second part of the question asks you, in what interval is the function increasing? So if a function is increasing in an interval I, so if a function f of x, or let me use f of t, is increasing in an interval, let's say a to b, then for all x belonging to that interval, the derivative of the function would be positive. So I just need to check. Let me just replace this with t, because I've been using the variable name as t, so it's advisable that we use the variable name as t. Now, so the derivative of this function is positive in this zone. As you can see, I'm just identifying the part where the function's derivative is positive. So clearly from the diagram, your function derivative is positive in the interval minus 6 to minus 2, or from 2 to 5. So this is the zone where the function derivative is going to be positive. So we answer this part of the question also. Now, next part of the question is find the absolute minimum value of the function in the interval minus 6 comma 5, right? Now, the derivative of the function becomes 0 at these 2 points, correct? And the function starts increasing at minus 6 and 2, correct? And the function endpoint is at 5. So when you're finding the minimum value of the function derivative, you're finding the minimum value of the function in an interval, we need to check what are the values of the function at the corner points, which is minus 6 and 5, and we need to find out the value of the function at the points where the derivative is becoming 0, which is minus 2 and 2 as well. Please note that the function can have an absolute minimum even at the corner points. Now, a little while ago, we derived f of minus 3, which is 3, f of 5, which is going to be 7 minus 2 pi plus 3, which is going to be 10 minus 2 pi. Okay. F of minus 2, we need to find out from this information, which is going to be a 7. And f of 2. So for f of 2, again, I'm going to use the fundamental principle of integral calculus. So from minus 2 to 2, f dash t derivative of t of the function, integral from minus 2 to 2, which is going to be just this area. So it is 7 minus 2 pi. Now, out of these 4 values, whichever is the minimum, that gives you the minimum value of the function. So as you can see here, 7 minus 2 pi is the minimum of all. So the minimum value of this function, the absolute minimum value, is going to be 7 minus 2 pi, right? Now friends, let's talk about, let's clear this up. Okay. Now let's talk about the last part of the question. The last part of the question says, find the value of f double dash minus 5 and f double dash 3 and explain why it does not exist. Okay, so f double dash 5 means we need to find out the slope of the function at minus 5. So which is going to be your slope of this line, right? The slope of this line is going to be just y2 minus y1. Remember, the coordinates of this point is minus 2 comma 0. So y2 minus y1 by x2 minus x1 is going to be 2 by minus 4, which is going to be minus half, right? So f double dash minus 5 is going to be minus half. But what about f double dash 3? Now, because there is a formation of a corner at this point, no, the derivative at 3 does not exist, because we know from the basic differentiability criteria that a function is not differentiable if there's a formation of a corner or a cusp or a sharp turn at that point. So f double dash 3 does not exist. But however, if you have to give a logical reasoning for it, the left-hand derivative at x equal to 3 is going to be the slope of this line. The slope of this line is going to be 2 by 1, which is plus 2. And the right-hand derivative at 3 is going to be the slope of this line, right, which is going to be minus 1. So since left-hand derivative and right-hand derivative are not equal, we can say that the derivative of the function, the double derivative of the function at 3 does not exist. So hope guys you enjoyed this session and I try to solve this question within 10 minutes for you. Thank you so much for